After my colleague who presented the broadband and the broadband mobile trends, which is the most or the biggest competitor of the broadcaster from the point of view of spectrum. Let me very quickly and very briefly try to take you over a vision for future of digital television. And on that point, I would like to mention that this presentation is the result of my own searching and ideas. I don't dare say a vision, so it's in no way an ITU position, to be clear. So, why terrestrial broadcasting? Not only because I am head of the broadcasting services and this is my job, but also because of the strengths that are, for example, the free-to-air, wide public reception also is always possible, both in cities and rural areas. It also provides localized content, which is tailored to the cultural and linguistic needs, as we know that for the DTT, and I mentioned in digital terrestrial television, we have also the regional broadcasting and even very, very local ones. It is known to everyone that also the digital television or the traditional television is known for being less affected by weather conditions, for example, when heavy rain or that can disrupt. And as an example, satellite signals. I am not attacking any other way of television. So it's also most trusted and followed media in some events. I will come to that later. It also has proven that it is very efficient during disasters and efficient also for public warning. Ongoing digitalization is also providing better quality, more choice, and new features as for the digital television. Now, of course, there are many challenges, and the biggest one, as I just mentioned in my introduction, is a lack of frequencies. For television, it's mainly the UHF, and UHF, I mean, it's being competed with by the mobile services, the 800, 700, and a portion of the 600, and only in few countries, I wouldn't say has gone, but are shared with the, on a primary basis with mobile, and we know what it is. I'll come also to the difficulties on having DTT close to neighboring countries that have mobile or vice versa. There is also the increasing competition because there is not only the digital television and satellite, but there is also the streaming, OTT, IPTV, cable, and others. This also, I mean, causes the reduce in advertising revenue, which makes life difficult or more difficult for operators to sustain the digital stations. Lack of two-way communication, because we know that broadcasting station is transmitting to a region or to a coverage area, so there is no other way back to communicate to the station. And of course, we all know, I mean, years ago I was hearing people speaking about young generation, but I can assure you that even us old people, we have changed in habits, and we use more the phone or tablets or other things to stream and to broadcast or to watch broadcasting. So what can we expect? We can expect that with second generation, such as DVB-T2, IDBT, ATSC3, etc., we will have high picture quality and also audio efficient spectrum use, and also data services. I don't know how many of you, 2 or 3 weeks ago, there was a workshop done by 6A, and there was a great demonstration. And also here you have demonstration of technologies, etc. So you could see the advance in HDR and also 5G broadcasts that were demonstrated live. That was really good. We have also the IP-based for mobile broadband combination, like such as the ABB TV. Integration with 5G broadcasts, which can, in addition to the advantages provided by the normal or the traditional digital terrestrial television can provide the possibility to communicate with the mobile devices. And also there is a convergence of linear TV and streaming. And here we have hybrid models, catch-up TV and apps. In case you missed a program or a TV show, you can use the catch-up TV to watch it again or to record it, etc. So many things. The second DTT generation, I said what to expect. So it depends to who expects that. The spectrum refarming, which is by reallocating TV spectrum to mobile broadband services due to the high demand for data. TV spectrum is expected to be reduced. This is, I think, the question that was raised earlier by our colleague Bashir. And this is expected to lead to the use of more efficient standards and compression techniques, which broadcasting world is doing, and continuing the research and the improvement in that way. And also the use of the SFN that reduces interference and make more efficient use of the available or the allocated spectrum, I would say. The second point concerns the sustainability and cost efficiency. And of course, there is the investment in lower costs to reduce environmental impacts, but also the cost-effective broadcasting, if we compare with other means, including satellite, cable, the DTT remains most efficient or the less costly. And then we have the very important point, which relates to the universal access. And here, the free-to-air broadcasting remains a primary source of news, as I mentioned also earlier, and information, especially in rural and underserved areas. And I don't need to remind you about the COVID period, where we had many countries in the world for the educations that did not have the mobile devices or internet or both, and they relied on TV and radio to continue their education during the period of interruption. It's also a reliable choice for emergency broadcasting and public services. Now I will try to focus on the 5G broadcasts. And here, what do we expect, or what do some expect? So 5G, what is it first? It is an broadcast, sorry, because the normal 5G, it was presented already by Carles. So 5G broadcast is an innovative technology that integrates 5G network capabilities with traditional television or broadcast media. And the purpose is to deliver high quality, mass scale content over 5G networks. Standards, I'm just giving examples so nobody gets upset, or no region. So example of the FE-MBMS and TTMB system, respectively from 3GPP and HC. And the key features of the 5G broadcast is high quality content delivery, 4K, 8K, HD, immersive data or media, etc. Effective spectrum usage, that's what is expected. So remember the title. Allows for a single transmission to serve multiple devices at once. The other point concerns the multi-device accessibility. Of course, it can access a wide range of devices, smartphones, tablets, whatever, TVs, smart TVs. And multicast technologies, which is the broadcasting content to many users simultaneously for efficient coverage, not point to point, but the principle of the traditional DTT, which is a broadcasting station transmitting to a whole area. So the use cases of 5G broadcasts, live events, public safety, public media and entertainment, IoT and connected devices. And I think that we had a concrete event, which was the last summer, which was the Olympics in Paris, and where this technology was intensively used. And again, in that demo 3 weeks ago, it was the same material was here in ITU and demonstrated with. So 5G broadcast and DTT, the similarities is that both they use high tower, high power, or low tower, low power. There's no restriction. They're based on the OFDM signal. They can use SFN, single frequency networks, or MFN, multiple frequency networks. And also they release 17 for 3GPP. The only complication that the 3GPP had is that it wasn't, how to say that, it didn't contain the specifications for 6, 7, and 8 megahertz bandwidth, and now it was added in the 17. And this is very important because the traditional digital television is based on 6, 7, and 8 megahertz. The key spectrum bands used or considered for 5G broadcast include, I started with the UHF, so the 470, 694. Traditionally, and on the table of allocation, it's still broadcasting. It is known for the good coverage and penetration, and therefore it is ideal for broadcasting purposes, but it can be also considered for 5G broadcast. The 700 megahertz, some countries already reallocated portions of this band from traditional TV to mobile broadband. And this is because of the balance between the coverage and capacity. The L band, some regions use this spectrum already for broadcasting applications for its advantages, including the balance also between bandwidth and coverage. 2, 3, 2, 4 gigahertz, it can be used for broadcasting or other mobile broadband. And the C band, 3, 4, 3, 8 gigahertz, typically used for mobile broadband, can be also repurposed for broadcast type services if necessary. For the millimeter waves, these bands normally are used for high capacity or short range communications, but it is also potentially targeted for 5G broadcast services, and particularly in dense urban areas. So the coming or the improvement that is expected from 3GPP in release 18 is to include the bands 612 to 652 megahertz and 470 to 698 megahertz downlink. And this also, it will be the continuation in WRC 27 and 20 and 32, sorry. So the spectrum aspects and challenges, the usage models, there are mainly two, the dedicated spectrum. So if the 5G broadcast will use dedicated spectrum, it will absolutely be in the same situation as DTT. So dedicated spectrum means efficient content delivery without congesting the network, because it shouldn't act as a network. And the other point is the proper spectrum allocation that would ensure a wide area and good indoor coverage. From the other side, there is the other model, which is the shared spectrum. And in this case, 5G broadcast will have to share spectrum with other services like mobile broadband, DTT, and this is by using the dynamic spectrum sharing. The challenges for this is, of course, the competition. So 5G broadcast will compete with mobile broadband applications, the other ones. Spectrum is limited. There is more and more demand and growing demand. The frequency coordination, and that's what I mentioned earlier, is that between different countries, when they have different allocation, one allocating to mobile and the other to broadcasting, it makes operation of both services, but mostly IMT suffering from interference. And also ensuring 5G broadcast doesn't interfere with existing wireless and mobile networks. So that's also a complication or a challenge. And finally, to find the right or to establish the right technical solutions required for dynamic spectrum sharing. Now, the operation and deployment challenges. There are many, and I tried to focus on 7 here. So the first one, network architecture, and it's of course known to everyone that it is complex to implement a nationwide 5G broadcast. It will be a complicated network. Infrastructure costs, the high initial investment and network updating to support broadcast capabilities. You have to count with that. And of course, the operational costs for a nationwide 5G broadcast network. And all this you need to compare with the DTT or traditional television station. Latency and quality of service, especially in densely populated areas with high demand. Device support, many existing 5G devices do not support 5G broadcast features. Standardization and harmonization, and many colleagues today, this morning and earlier session, they mentioned the importance of harmonization for economies of scales and other advantages. And of course, the lack of the harmonization may lead to fragmentation across different regions or networks. So therefore, there is a need for global cooperation to ensure interoperability and efficient use of spectrum, in addition, as I said, to economies of scale and other points. Spectrum licensing. The countries must allocate sufficient spectrum for 5G broadcast if they want it to be implemented nationwide. But broadcast spectrum is often controlled by governmental agencies or ministries, and therefore subject to lengthy regulatory processes. So the mindset also needs to change accordingly. And finally, privacy and security aspect. And here it is not easy to manage data privacy in a mass distribution context while delivering personalized content to consumer. And one other important point, in my view, is securing broadcast content from unauthorized access or manipulation. So that is also to bear in mind. Now, regulatory framework examples. Here, just the example concerning the UHF, to give the example of the radio regulations in case of implementation. So, of course, on the international level, we have the radio regulations and we have regional agreements. Here, the example of the UHF band, which falls under the Geneva 06 agreement for VHF and UHF band for region 1 and Iran. So let's suppose that a 5G broadcast station will be implemented outside the Geneva 06 area. So in that case, of course, if there is a 921 condition, it should be applied ahead or before. Here, the application of the provision 1131 of the radio regulations, which means that the allocation is there for the mobile, so the station can be recorded in the MIFR. Now, there is a second case if this station falls under the Geneva 06 agreement, and in that case, there are two verifications. It was also mentioned by Sujiva and I think also Nikolai. There is the need to check if the allocation is existing. And the 1134 is specifically to regional agreement, which we call the conformity examination, which means that the notified station must respect the envelope of the broadcasting station planning tree. So it must not provide or cause more interference or request more protection than the station recorded in the plan. And here, of course, for all administrations, they need to target, as I said, a broadcasting station in the plan. And for the countries, part of the footnote 5307A, which concerns the frequency band 614, 614, 94. So there are two possibilities, is to target a broadcasting station or to modify the list, because it is a mobile station at the end. Other example of regional approaches, Europe, there is more or less a focus on UHF band for potential 5G broadcast use and ongoing discussions about spectrum allocation for TV versus mobile services. So nothing decided, still discussions. USA for the ATSC 3 is the primary broadcast standard, and there is less focus on the 5G broadcast in UHF. However, broadcasters are exploring using some of the lower bands. And for Asia, mainly the examples of China and Korea, they are using the portions of the mid-band 3.5 gigahertz for broadcast-related services with a focus on mobile first 5G deployment. So, issues to be addressed, in my view. Collaborative efforts. Industry cooperation between mobile network operators, broadcasters, and regulators to align on standards and best practices. The innovation in spectrum management, of course, to provide solutions for spectrum sharing and flexible spectrum usage to overcome bandwidth limitations, but also the congestion or the lack of the frequencies. There is also a need to address the regulatory frameworks, as the government and regulatory bodies working on adapting policies need to keep in mind to balance the needs of traditional broadcasters and telecom operators, address the key technical and regulatory challenges facing 5G broadcast, because still studies are ongoing, standards improved, etc. And also a call for global collaboration and innovative solutions to create a sustainable terrestrial television ecosystem, independently of the technology that will be used. For the end, and to conclude, key takeaways, if we say DTT versus 5G broadcast. For mass broadcasts, such as live TV, news, events, as I mentioned, DTT is still the preferred choice due to its reliability, wide coverage, and established infrastructure. It remains strong for traditional linear and public broadcasting. Now, if we look from the side of mobile and on-demand content, 5G prevails, especially for delivering content to mobile devices, by supporting interactive feeders and integrating with internet services. And also, it is well suited for urban areas and personalized viewing experience. Now, from the cost and infrastructure point of view, DTT has a cost advantage, as I said earlier, whereas 5G broadcast requires significant investment because of the initial investment, but also of the maintenance of the networks. For the coverage, for the same DTT coverage, a dedicated 5G broadcast network would require a substantial number of additional sites. Knowing that more sites mean additional interference issues, hole punching, more bandwidth, more frequencies, etc. And hybrid models, the future might involve hybrid models, combining DTT for traditional broadcasting with 5G broadcasts for mobile and on-demand services, maximizing the strength of both technologies. With that, I conclude my presentation, and I thank you very much for your attention and patience. Thank you very much.
Ilham, I think it will be very helpful if we can understand, probably if not in this session, in the other session that's coming up, the standards or the specification for the 5G broadcast. Because what comes to mind is investment. When we're talking about broadband delivery of 5G services, we can think of where investment is coming. We know that private investors are there ready to invest in deploying these services. Can we say the same thing about the 5G broadcast systems? Or is it governments that are going to invest to put all the network across their countries? And what will be the expectation in terms of sustainability of that particular model? Now, another question that also comes to mind is, another question I have is, this is now for the earlier speaker. I think that would be Valerie, sorry, I'm sorry, I didn't remember the name, but it is to do with the discussion on the 5.307A, That is footnote 5.307A. In your opinion, what will be the best way to look at resolution 26, that addendum to resolution 26? How do we ensure that countries don't take advantage of it to block progress of others? What will be the test mechanism to say, because there was mention of affected countries? How do you determine what is affected? How do you balance the interests of the two without causing immense frustration to one side using that particular provision? That's to remove the unintended consequences of that provision.
Thank you very much.
Thank you.
Okay, so I tried to answer the first question, but giving concrete answer because this is not in my hands. But I would say, I mean, if I understand correctly your question, it's about the business model. The business model is under discussions. The government, if they step in, it would be mostly for the utility of the population, to cover missing service or to complement some other services. From the other hand, the operators, if they don't see that there is business behind and there will be benefits, they won't be. And that's one of the challenges that I mentioned, that most of the devices do not have the 5G feature. So all of this are still in discussions. It can change. Honestly, I have no idea where it goes. But maybe the combination of 5G broadcast and DTT could be a solution that would be probably implemented by both if there is an understanding. We know that many countries, for the universal access, they will have a percentage or services that they impose on the operators. That could be a way to do it. Only the future will tell us. Thank you.
If I understood correctly, the second question was about footnote for allocation, which allocated the band 614, 694 to mobile service in 11 Arab countries. And Dr. Bashir asks how other countries can join this footnote, for example, at the next World Radio Communication Conference. The process of joining of footnotes, it's described in Resolution 26, Annex 1, and it says that in exceptional cases, when the band is outside the agenda of the conference, countries still may ask to join footnote, and may join footnote subject to absence of objections from affected countries. And his question was how to identify these affected countries, who is affected, who is not. So this question is asked every conference, and we always reply that it's between countries. So we don't have in any document of ITU the definition of affected countries. We just add that it should be reasonable objections, that some calculations of interference should show that the country is really affected, but then it remains on the decision of affected country. And we had some cases at previous conference when, for example, country in the south of Africa could not join the footnote because one European country was objecting it, and it was in gigahertz band. So, and it was not accepted, this joining of footnote. So, Dr. Bashir, unfortunately, we don't have well-established criteria to identify these affected administrations. Please be reasonable in calculations. Thank you.
Thank you very much indeed, Ilham. Thank you, Nikolai. We have one more question I can take from the back there from France. I think you had your hand raised before.
Bangladesh. Yeah.
Sorry, gentleman from France there. Did you want to ask the question? You had your hand raised before? No? Okay, sir from Bangladesh. Okay, last question. Thank you.
Thank you so much. I have one question to Mr. Nikolai regarding the WRC 23 outcomes. The spectrum band 3600 to 3800, it is already identified for IMT in region 2 and region 1. But for region 3, there is no such kind of allocation in footnote. However, some countries, some administration in region 3, they already have assigned this band for 5G. So Bangladesh administration also would like to assign the spectrum for 5G. So is there any regulatory bindings for us? There is no footnote for region 3.
Thank you for this question. It's normally the approach that you may use any service within your country until you start to create interference to your neighboring countries. You have full rights to govern service and make license. In the terms of international regulations, this usage of this licensing will be qualified as non-compliance with radio regulations. You will automatically use this this service, IMT service, on non-interference, non-protection basis with respect to neighboring countries. But if you have agreement with them, you may consider that, but it's your national decision. Frankly speaking, I missed exact the band. The band already allocated to mobile service and not identified for IMT?
36,
not allocated.
3600 to 3800.
For this band is different. So for this band is, I think in region 3, there is allocation to mobile service already. 3.8 gigahertz, that's correct?
Yeah.
Yeah, there is allocation to mobile for region 3 in this band. So it means that you may license your IMT even this band is not identified for IMT. We have decision of the conference WC 19, which in fact allowed to use the bands which not identified for IMT, but allocated for mobile, and you can use it for IMT. So for example, there is band allocated for mobile, there is no identification for IMT, but conference 2019 allowed to use this band for IMT. We may talk a little bit more in details with you if you would like. But again, if the band is allocated to mobile, you can already use it for IMT. It's not, I would say, very much recommended, but it's your national decision to do it.